In this video, we're going to discuss some entropy. So entropy is a measure of the disorder in a system. The greater the degree of disorder is going to be favorable, and we want to look for positive values in delta S. So nature is going to favor the tendency toward more disorder. So if your products are more disordered than your reactants, then the reaction is going to have a positive value for the change in the entropy. For example, evaporation is going to give you a positive delta S value. Molecules go from being fairly tightly bound together in the liquid state to being really randomly dispersed and disorganized in this environment, in the air. Dissolving ionic compounds is also going to give us a positive delta S. So we go from this nice structure of being tightly packed together here in our sodium chloride compound. We get in water, and the water is going to pull apart those ions into a more random disorder. So what is S? We look at the entropy of the products and we look at the entropy of the reactants. These are numerical values that are related to the number of possible ways that the molecules can be arranged with respect to one another. So let's look at this example. We've got knickknacks or beakers or jars on a shelf. Every time we rotate or move one of these, then we've created a new arrangement. The greater the number of possible arrangements, then the greater the S value. So the more particles you have to arrange, then there are even more possible arrangements, so the S value becomes even greater. So in this picture here, we have tons and tons of bottles. So there are probably millions of different ways we could organize these particular bottles. So the greater the number of the possible arrangements, the greater the S value. Now the S value for a given species is going to be constant under constant conditions of pressure and temperature. So what is the change in entropy? What is delta S? It's products minus reactants. And if the difference is positive, then this means that there is more disorder. So for example, if our reactants are 4 eggs, let's say that there's 10 ways to arrange these different eggs. Okay, so if you have a small number of reactants, then you've got a limited number of arrangements. Now let's say our products here are a dozen donuts. So we've got a dozen of these donuts, so we have a much greater number of possible arrangements. Let's say that there's 8,900 ways to rearrange these dozen donuts. So for this example, delta S is going to be a positive 8890. So the amount of disorder is going to increase from reactants to products. So again, increases in entropy are going to be favored. More disorder in nature is what everything is striving for. For example, you have to put work into keeping your room clean. It gets dirty naturally, dust, you bring your books in and throw them around. So it takes work to keep it organized and orderly. Stir fry. Without this increase in entropy, you couldn't make stir fry. All of your peppers would clump together, the chicken would be together, the spices would clump together. So by increasing the randomness of the system, everything becomes evenly distributed. For a lawn, some men like to have a perfect lawn, but you got to put a lot of work into that. Other plant species grow in there, you got weeds, and to keep all that from happening, you have to take care of it. Spilling a glass of milk. Milk goes from being contained in a glass to being all over the floor. It would take a lot of work to get it all back into the glass without getting any dirt in it. Same thing for breaking a window. It would take a lot of work to put a broken window back together.